All right, so we are back at home days and at school days. So for this Monday, 12/7, we're going to look at rhombi and squares. So two special cases of parallelograms again. So this video is going to run you through the notes for today. You can go ahead and print a blank copy or complete a blank copy in your OneNote notebook as I run through them. So first thing we're going to start with is we're going to start with a rhombus. So a rhombus is basically a parallelogram where all four sides are congruent. All right, so this, a lot of times people have a misconception that this has to be a square, all right, but really this can be much more that diamond type shape, all right, where we have something like this, where we maybe the opposite angles one way are equal and the opposite angles the other way are equal, but they're not all 90 degrees. All right, so a picture like this, all right, would be a prime example. Now, knowing the definition, a rhombus is a special case of a parallelogram. All right. And that is because in this one, both pair of opposite sides are congruent. All right, and if both pair of opposite sides are congruent, that's enough to tell us that a quadrilateral is actually a parallelogram. Now, that means all the properties of a parallelogram, right, are in play here. So very much like what we saw Friday, where all the properties of a parallelogram held for a rectangle, all those properties also hold for a parallelogram. So if I jump back up real quick to our graphic organizer that we've been working on, all right, today what we're going to look at is we're actually going into this section of it. All right, so this is a rhombus. All right, and for rhombus, the first one we have is we have four congruent sides. All right, that's our first of our properties that we have to work with when we're dealing with a rhombus. All right, so we're going to jump back to the notes that we were just working on here, and that was 12/7's notes. All right, so we've got a couple other rules that go with a rhombus. So the first one's the diagonals of a rhombus. If we look at this one, all right, the diagonals actually, and a lot of times I like this just from a visual standpoint, if I draw one of these, all right, and I draw in my diagonals, all right, notice how it looks like we get a right angle there? And that's going to happen really, even if I stretch this out the other way, all right, we're still going to have that situation where we have that very nice symmetry in this, and we're going to end up with that right angle. So the diagonals are perpendicular, all right, when you're in a rhombus. All right, so we know that we get a 90-degree angle there. Now, the converse of that is also true. So if the diagonals of a parallelogram, if you know something's a parallelogram, and they tell you, like in these pictures, that the diagonals form a right angle, that's going to be enough to tell you that it's a rhombus, right? Because we're going to make a lot of those distinctions of what shape is this down the road. So we're going to have forwards and backwards rules. So if a diagonals of, so if you know it's a rhombus, then we know the diagonals are perpendicular. But if we know it's a parallelogram and their diagonals are perpendicular, we also get it's a rhombus. All right, now the next theorem here is each diagonal of a rhombus, all right, bisects, so cuts perfectly in half, all right, a pair of opposite angles. So if I draw another example here off to the side, all right, and we say this is a rhombus and we give it the mark so we know, all right, if I draw on this diagonal, I know that it's going to cut each side of this into congruent pieces. Now, the reality of this is actually all four, the top, the bottom, the right top, and right bottom are all going to be congruent. All right, so we're going to get four congruent angles out of that. Now, if we bisect the top, it's going to if we bisect with a vertical one here, which I'll do in blue, all right, that would give us the same thing happening, all right, and they'd be four congruent angles again, but those four wouldn't necessarily be congruent with the other four, all right, unless we happen to be in a special case of a rhombus, which we'll talk about a little bit later today. All right, so the next one says, if a parallelogram has one diagonal that bisects an opposite pair, a pair of opposite angles, then it is a rhombus. All right, so this is actually our converse, all right, from theorem 6.16. All right, so again, it goes forwards and backwards. So we're going to be able to determine something if we know it's a rhombus. We're also going to be able to determine that a certain given parallelogram is a rhombus. All right, and then the last of these here is if a parallelogram has one pair of consecutive sides that are congruent, then it is a rhombus. All right, so basically, if I know I have a parallelogram, like let's say this one, all right, and I know it's a parallelogram because maybe they've marked it up like that. If I know consecutive sides are congruent, that gives me enough to say the whole thing is congruent. And again, the reason why is if it's a parallelogram, opposite sides are congruent. So I can come over here and mark this one. All right, I can also go over here and mark this one. And now I've got 4 congruent sides all the way around, which would force my hand that we'd have a rhombus. All right, so let's go back to that graphic organizer real quick up here. And we'll fill in a couple more pieces of information. All right, so we said 4 congruent sides, perpendicular diagonals, all right, and then diagonal bisects. Ooh, sorry about that. So diagonal bisects opposite angles. All right, so the diagonal bisects opposite angles. So if we jump back into those notes, now let's look at some problems. All right, what I'd encourage you to do is I'd encourage you to go ahead and pause the video and try these 3 problems real quick. And then when you're done with them, go ahead and restart the video, see if you agree. All right, and it says, given the rhombus ABCD, so they're telling you what a rhombus, answer those questions. So go ahead and give that a shot. Give me a pause. All right, so hopefully you gave those a shot and you're back now. So the first one says AC is perpendicular to. All right, so when we look at this, we know in a rhombus, the diagonals are perpendicular. So that AC is going to be perpendicular to DB. All right, we're going to have those perpendicular diagonals. Then it says that DAC, so angle DAC, and again, I'm just going to mark that here so we can see it. So DAC is congruent to. Now, this is where we're going to use that the diagonals bisect opposite sides. So we're really going to end up with 4 angles here, all right, that are all congruent. All right, and it's those 4 that I've kind of marked in blue. So they told me DAC, so I'm going to go angle BAC next. All right, so the first one, second one. Then I'm going to go to BCA, all right, which would be the third one here. And then I'm going to go to DCA, which would give me the 4th one right there. All right, now I'm going to work my way around on the other 4 that are cut by DB. So we have ABD given. So I'm going to do CBD next. All right, and then we'll go CDB. All right, and then we'll go ADB. All right, and that'll take us through. All right, so that's basically going in the forwards direction. We know it's a rhombus, and we want to make some conclusions from that. Now, sometimes we're going to be asked to go in the backwards direction, like number 2 here. All right, so in number 2, it says rhombus or not. So first thing that I notice, all right, is I have a diagonal here that's bisecting opposite sides. So I'm going to go back and take a look at that rule. And the rule says, all right, if a parallelogram has 1 pair of consecutive sides that are congruent, nope. All right, if a parallelogram has a diagonal that bisects a pair of opposite angles, then it is a rhombus. Now the key here is, notice they say a parallelogram. So I'm going to look to this picture, and the first thing I need to decide is if it's even a parallelogram. All right, so when I look at this one, all right, I try and look for any of my parallelogram rules. So if we jump back to our graphic organizer, we know parallelogram, opposite angles congruent. We have 1 pair, but not both pairs, so we don't have that. All right, both pair of opposite sides congruent. We don't have that. All right, consecutive angles are supplementary. We didn't have that. Diagonals bisect each other. We didn't have that. It gives us 2 congruent triangles. We didn't have that. Opposite sides are parallel. Again, something that we didn't have. So let's check again and make sure that we can't come up with any of those. All right, and what I notice here, and this is where we got to be really careful because it can be sneaky. All right, because in this one, that led us down a path. But when it said opposite sides are parallel, notice that here, if I look at this angle that I'm filling in blue, and this one. Those are alternate interior angles for this side and this side. All right, and then the two that I'm going to fill in red here, those are alternate interior angles for this side and this side. So now I have opposite sides are parallel, so it is a parallelogram, and I have a diagonal that bisects opposite angles. All right, so this is yes. All right, this is a rhombus in that first one. All right, now if I go to the second one, I've got the parallels marked, so that I get for free. All right, it is a parallelogram. And then I have these markings here where it says that it's a 1 mark, so each of those are the same length. So now I have consecutive sides, all right, of a parallelogram are congruent. That's enough for me to say it's a rhombus as well. All right, and then if I go to the third one here, I have one pair of opposite sides are parallel, and then I have consecutive sides congruent. It was kind of sneaky and hidden down there. I apologize on that. Wasn't the best formatting. So now when I look at this, might be stuck a little bit. So we really just want to think what other options there are. So I could have the same type of thing, and let me change that up just a little bit. All right, if I did something like this, all right, this could very possibly have those exact same markings, all right, but that's definitely not a parallelogram. So because this is not a parallelogram, we can't even consider it being a rhombus, so that one is a no. All right, so that's our second one there. And then if we go to the third one, and we've got a little bit more practice with this and then square. All right, I'd like you to go ahead and try 3, 4, 5 through this page, and I'll give you another video here real quick that'll summarize that for you.